5.1 Composite Functions. So we've done some work with functions so far. For example, we have been given maybe two functions like this, and then we've done maybe like, what it happens when you add the functions. You can obviously multiply them, divide, subtract. So that's the kind of work we've done so far. A composite function is similar. What a composite function really means that you take one function, in this case we're taking g of x, and we're plugging g of x into f of x. So where it used to say, well, f of x equals, now we're going to plug in, now we're going to say, well, the x value that we're taking, that's going to be a new function, and we're going to shove that whole function into f, and then we're going to do what f usually does with that as our variable. The notation is given here, so this is read as f composed with g. You could also say f of g, and f composed with g is actually when you put g into f, so it's sort of backwards. G is going to go into f. Okay, the domain for this new expression that we'll get is the set of all numbers of x in the domain of g such that g of x is in the domain of f, and that's a little bit harder to follow along, so let's just see what that means sort of maybe in pictures. So the domain of g is right here, and that has a lot of x's. So it has a bunch of these, and there are some more x's over here, and that creates a range. And so all these x's create a lot of values, and then what we're going to do is only take those values out of the range of g that are also part of the domain of f. So we're only using range values of g of x that are in the domain of f of x. And so those values then end up creating a range for the function, and that may or may not be identical to the range of f. It doesn't have to be, sometimes it is, but it's going to create a set of numbers that are the range of f of g. So the values that are in the range of g that fall in the domain of f, using that creates a possibly smaller, creates a possibly smaller, so it doesn't have to be, but it does create a set. So this creates a set of range values for f of g of x. Okay? So that's sort of the idea here. So how is that going to work? Well, suppose they were given these two functions, f of g, or f of x and g of x, and then we need to find f of g of 1. Well, the way I would do it, so this just means figure out what g of 1 is. Well, that's 4 plus 1, which is 5, and then stick that range value into f, if you can, and then figure out what f5 is, which is 2 times 5 squared plus 3, so 25 times 2 is 50, so that's 53. G of f of 1 would mean that you find out what is f of 1 first, which in this case is 5, and put 5 into g. So now find out what value function you would have at 5 for g. So we're going to do 4 times 5 cubed plus 1, so that's 4 times 125 plus 1, so that's 501. So there's a huge difference in the two values. You do the same thing with c. And this is sort of weird, but you're going to put f into f, so this is f of f, so what value do you get at a negative 2? So 2 times a negative 2 squared plus 3, so that's 4, 2 times 4 is 8, plus 3 is 11. And now figure out what f11 would give you. So 2 times 11 squared plus 3, so that's 121 times 2 is 242, so that's 245. Doing the same thing here, put negative 1 into g, so that's a negative 4 plus 1 is a negative 3, and then plug in a negative 3 into g again, so 4 times a negative 3 cubed plus 1, so that's a negative 27 times 4, that is 80, negative 108 plus 1 is a negative 107. So I would do it that way. You could do it algebraically by finding the composite function first and then working with it, but I think this is just faster. Okay, using the tables, so this is f and that is g, find what? F of g of 2. So find for this one, for the first one. So I need to find out what's g2, so that's 4, and then what's f4, which is 7. So you get 7 out of that. And here you go backwards. F negative 1, so that's 2, and at 2 you should get 4, so this one gives you 4. Okay, what about finding the main? So find the domain given f of x and g of x. And so it's telling us that g of x must be defined, so any x not in the domain of g must be excluded. So first of all, and again it's sort of working backwards, so it says f of g, so look at g first. So g of x says 4x minus 2, x cannot equal 2, and then so this was 1, and then now I need to look at the composite function, so I'm plugging g into f, and that's a little annoying, but it means that I'm going to do 1 divided by 4x minus 2 plus, so that was g, that's instead of x now, plus 4. So I got to figure out what this is. So 4 over x minus 2, I'm going to use x minus 2 over x minus 2, so that is plus 4x minus 8, all of that in one fraction. So flip the fraction, so x minus 2 is going to be the top, and in the bottom you get 4x minus 4, and out of this one we know that 4x minus 4 can't equal 0, so that means 4x can't equal 4, so x can't equal 1. So the domain for this function will be all real numbers, except x cannot equal 2 and x cannot equal 1. Yeah. Okay? Okay. I'm going to find this one and then find the domain as well. So since I have to find the domain, so f of g, let's look at g first. So g of x says the square root of x minus 1. So x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. Now I'm going to shove g into f, so f of g itself would be 1 divided by, so all of this is going to be plugged into there, so that becomes the square root of x minus 1. Well, that ends up with a fraction, so I also cannot have the square root of x minus 1 is not allowed to be equal to 0, so that means x minus 1 can't equal 0, so x cannot equal 1. So if I then look at the domain of the composite function, x has to be greater than or equal to 1, and x cannot equal 1, so I would say then that the domain would be all real numbers, and x has to be larger than 1. And the composite function is right there, so let's copy that as part of the answer. So it is 1 divided by the square root of x minus 1. Okay, what does that look like if I do f of f? Yep, let me give myself some space over here. Let's do this. Okay, so the function f of x if I consider that one x cannot equal 0, then I'm going to plug 1 over x into 1 over x. So f of x is 1 divided by 1 over x, which is just x. And that has an unlimited domain. Other than you can't use 0 still. So the domain will be all real numbers except x can equal 0 based on this one, and then that one is pretty good. So we can leave that. Okay, so that's how you find your domain. Calculus application, that sounds sort of fancy, but so what's given here is f of g is h, and f of g apparently is this. So the composite function that we're supposed to be working with is the square root of x squared plus 1. Okay, so this is sort of like a puzzle. We're now being asked, like, what parts did we put together, for example, to come up with this? Well, I see a square root, so the square root of x is probably one of the components. And then this x has actually been replaced with something else. So let's see. Well, let's not label them yet. I'm ahead of myself. So the other function that I have then would be x squared plus 1. So this one needs to be plugged into there. And since it says f of g, that makes this one g of x. And then if I call that one f of x, then this should work. The composite function should give you the square root of, replace the x with x squared plus 1, and then you're right. So that's one option. You also could have started with the square root of x plus 1, and then you could say, so if that is f of x, and then g of x could just be, so now if I replace the x with an x squared, I get the same thing. So there's more than one way to do that, and that's sort of the neat thing in calculus, is that you often can find multiple answers for one question. So here this would definitely have 2 right answers. And the trick then is to find what works best for your given situation. So in this case, I mean, I really don't know what to tell you because I don't know what we actually would be trying to solve here, but 2 ways to get there. So sort of the same thing over here. So here's one way to look at it. So I see 1 divided by something. So that could be a 1 over x. Then if I replace that x with 2x squared minus 3, then these two together would make the expression I have over here. So, well, this needs to go in there to make it work. And we're doing f of g again. So if I make that g of x and that f of x, then that will work. So that would be one way to do that. And then again, you could play around with this a little bit. You can, you could already write 2x minus 3 here. So you could say, well, here's another way to say, well, that's 1 divided by 2x minus 3, and then replace that one with the x squared. So this would also work. So there are probably more ways than that even. So, okay. Thank you.